All right, welcome to our third shells example. Once again, this is one that we could theoretically use discs. Our discs would look like this because what we are doing here is we are rotating the intersection of these two functions, y equals 4 minus x squared and y equals x, around the y-axis, around x equals 0. Now, this is actually one which I find interesting because if we were to use disks, what we would have to do is we would start by finding all of these disks, and then we would change gears and we would find all of these disks in order to find the volume of this. And so it's actually two completely separate integrals, one for the top function, one for the bottom function. And we have to figure out, well, where do they intersect so that we don't, so that we know where to split them up. So instead, what we're going to do is we are going to look at, and I'll quickly redraw it, but without all the fancy colors. We're going to look at a shell rotation where this is the thickness of our shell, and it is being rotated around the axis just like that. So let's think what we've got here. Well, first off, we need height. Let's go ahead and just for the heck of it, because colors are fun. The height of this function is going to be the difference of the two functions. The height of this function, or of this shell, is equal to 4 minus x squared minus x. The radius of this function is just x, which makes life pretty simple. So I know that the circumference of this function, is 2 pi r, which is 2 pi x. I've got everything I need except how far out do I go? Because I want to come out to A. I need the intersection of 4 minus x squared and x. And looking at this, I get 0 equals x squared plus x minus 4. Does not factor, but quadratic formula gives me an intersection of 1.562. Pretty straightforward and simple. So here we go. The volume of the shell is the width of the rectangle times the height of the rectangle times the thickness of the rectangle, which means that the volume, taking the sum and the limit, is the integral from 0 to 1.562 of 2 pi times 4x minus x cubed minus x squared dx. And because we got a 1.562 there as a boundary, we know it's not going to be nice anyway. So what the heck, let's just shove it into our numerical integration. And our numerical integration gives us 13.327 cubic units. We could have done this one, but then we were going to have to shove in a decimal. Anyway, boom, done. Let's do this the easy way. All right. So again, just a reminder, I will belabor the obvious. I will beat the dead horse. We need the radius of our shell, which gives us the circumference of our shell, because that is the width of the rectangle when we unroll the shell. We need the height of the shell, because that gives us the side of the rectangle when we unroll the shell. And we need to know which direction our thickness in, because that tells us our variable of integration for the thickness of our shell. And then volume, length times height times thickness, and we integrate that over the distance that we are rotating. All right. When I come back, we will talk about non-rotational, other kinds of three-dimensional cross sections. So we are done with rotating. Just a quick reminder: we had rotate to make discs. We can rotate around the x-axis, and we have vertical discs. We can rotate around the y-axis, and we have horizontal discs. But now we're stacking them this way, dy. We could rotate around a different axis, so we need to be careful with our radius because it would be our axis minus the function, or our axis minus or plus the function. We can rotate two functions around and come up with a washer that has a hole in the middle. That's pretty straightforward and simple. Or we can rotate around, creating a shell like a tree ring in a tree stump. And we can just add up all the shells, just starting in the middle and working our way to the outside, or vice versa, however you want to look at it, and adding up the volume each of the shells. And of course, each of the shells can be unrolled to become a rectangle of thickness delta x. All right, hope that makes sense. I believe I said, but maybe didn't write, my students do exercise 37, and we'll be back with non-rotational cross sections. Thanks for watching. Hope you learned something.